Swayam Prabha. Digital India. Educated India.
Welcome back to our discussion on bulk material transportation and handling system. We are now discussing about the mineral processing plant equipment. That is, though in the mineral processing, the bulk material handling is the most predominant operations, but this so far as this particular area screening, that's size separation. This size separation of bulk material is not only in the mineral processing equipment, it is also required in other industry like pharmaceutical, agriculture, food technology and all that. So, these screening operations are of basically we will be discussing here of two types, that is the large particle separation and small particle separations. The large particle separation we say screening, the small particle separations many times we say it sieving. So, we will be discussing this our in a mineral processing equipment as a mineral processing equipment, where do the screens stand and what is the present scenario, we will be discussing about it. So, our main objective here, first thing we will have to know why do we go for screening. So, the objective should be clear to us. Then we should be able to name that what are the different type of screening systems or the screen as a machine they are there, and also we should explain that how the sieving is done, because the fine particles their separation is very important, as we already told that when your the ore is to be handled and your main it will have to be beneficiated, then after that in the process you will find the fines play a big role, and sometimes we will be having some very fine where we cannot separate by sieving and then industrially. So, we need to go there even for the another operation called classification, that is classifiers are used. Now, of course, the sieving is necessary of the bulk material. Sieving is very important to do certain laboratory scale studies in the industry as well as in our academic world. We will have to know the materials properties. That is why your when you go for study of the size separation, sieving is very important, which is also in the civil engineering as a mining engineering, for soil studies, environmental engineering, there also they handle those bulk material, particularly the powder material for sieving. We will be touching upon that also. And then we should be able to discuss about the different type of screen, so that we can handle the selection problem. So, let us start discussing about this. So, what is the screening of bulk materials? It is a separation technique, because you may be getting a mixture of different material. When you blast, it will be giving different fragmentations. So, then again when you crush, that it will never give a uniform. So, the product of blasting or the product of crushing, it will be in a number of different size aggregates will be there. So, we need to screen them, that means to separate them. Now, that separation how it will have to do? You will have to do some standard that is your hole or a square or a rectangular or different shape of some perforations or a perforation plate, or there will be some gap through which a particular size will go. Screening is that, just allowing something forcibly to pass through certain or designated gap. And then after that you will have to have the arrangement in the screening system, this separated material go to their next destination. And then as I said, that sieving is basically for the small particles. Now, what is the basic principle of this screening? That is, we will have to do either you give a vibration or you give a oscillation, and then sometimes you may give a rotary motion. By that means you are creating a dynamic forces are induced into that, so that the particle move and they get subjected to the gaps or that screen holes or screen aperture, the word used is aperture. So, that they can get, and then we can do it over there. Now, in that the basic design of the screen, it will be depending on how the energy is used for giving that vibration or giving that acceleration. The engineering involved is transferring that energy to your screening platform, that and making your receiving the material to that screening platform and allowing them to move. Now, if you are doing a screening operations, if you put the material all at a time, but there is a only your screen will be, suppose a perforated plate is there. On the perforated plate, if you give at a time a lot of material, then you make them to vibrate or then move, then whatever there at the top, they will not get the chance of going through that hole, because it is already that blocked by the first layer. So, that means your screening is taking place only at the layer of this, that is your one layer of the material only will be getting seen. So, that is why what will be the retention time of those material on the screen, and then how only a monolayer will be placed on the screen, those things will be affecting your selection afterwards. So, you will have to know that how the machine has been designed and how it works, what type of layer or how much material it can come, or whether you are giving a time so that the material is going jumping like this. So, then what will happen, every time the material will be having a chance to fall over there. So, this the mechanism how it will be working will have to be known. So, as I said that objective of your screening, that is exactly your sizing or classifying, because the people different people will be requiring a different type depending on that where they are using. So, you are separating by size, it may also sometimes you will allow only the circular things to go of a particular, like that in the shape wise also can be screened. Then you need to do a scalping, that is also the removing the coarser fractions of the material, and then your grading, that grading is exactly the metallurgical plant, their process they be requiring a particular grade, that is your particular size, they will be giving a dimensions. So, accordingly you will be grading by the help of this screening system. Then there is a mineral processing where you use that is your magnetic media, that is heavy media separation, you may be knowing about in the mineral processing, because that is your you create a heavy media where the particles have been put it over there to make them float, and now that heavy media whatever the particle you have given, you need to recover them, there also you will be requiring some separation. And then another thing is there, that is also a separation. If you are having a weight, you have processed, the mineral is processed by the your mixing with water, then you will have to separate the water out, that is also a separation and some sort of a screening actions, that you know how the liquid part is taken in a tea strainer, that is also you are retaining the this your the residue or the tea leaves you keep it on the strainer, the liquid will go. So, that is also a screening, what is we can say sometimes as the filtering, this process is also a separatist. Now, sometime that is your dedusting, deslamming, that fine particle separation, different objectives of your screening is there. Then in your screening operations in the industry, in a mineral processing plant, will you take it for all type of materials? normally it is not, you will be having always working within a range. So, normally that 300 millimeter 30 centimeter and down to 40 micron, this is a normal, but depending on that you can have a tailor made machines creation is not at all a problem, provided if you have got a give a properly whatever you need, it can be done. Then there is a class, as I said, the classifier, there is another class of equipment and the system is there where you take out the very fine, that is particle less than 40 micron. If there is a valuable things, if you are processing some gold and then in the tailings gold in the effluents, very fine gold particles have gone, you will have to recover them, that also can be done by process where the classifier can be used. Then type of screening, that can be your dry screening and wet screening. So, there normally in the wet screening you go with a very small size up to your 250 micron 50 micron, and then in a 5 millimeter size in dry screening it is always done. So, although there are screen types that are capable of efficient size separation up to 40 micron, sizing below 250 micron is difficult by this screening system. That is why in the mineral processing they go for those classification. Now, you may be seeing some of the screening operations of different type of bulk material, say in our municipality waste. From there when you want to do that, that is also a screen which is a trommel screen. We also use in the mineral processing, sometimes separating some of the coal particles, there also we have got a trommel type, and in which the whole crushed coal will be given, the trommel will be rotated and your the finer, that is small size coal will be taken out, that is also there. In sometimes the coal breaker and the screen, that can be done if you allow a trommel, as you have seen, that is a cylindrical one in which there are holes. Now, sometimes a crushing and screening can be done for friable material, friable minerals or the coal. If you take them and then allow, you feed it from one side and make it to rotate, and then the coal or the friable material will go up and then fall down, and when they are falling down, because of these are all perforations, through that it can go. You can have a very different size of these particles, so that in the first sector you will be taking a very fine one separated, next one little bigger size separated, next one very bigger size, and then bigger than this size all will be going out. This is done in a trommel type of screen, which is used in that as in the coal washing and processing, or it is used also in the municipality waste, in the environmental engineering, your city waste where there are your organic and inorganic material both. Then if you use this type of trommel and when you rotate over there, because the organic particles they are not very hard, they can get crushed and then they can be separated out. Then whatever will be coming out, the non-organic material and the things which cannot be, they do not get separated. So, in this way the organic material which can be used for compost and other preparations are separated out. So, this a trommel screen is one type of screen you are having. Then the most common type of screen you will be finding, this is a vibratory screen. In a vibratory screen can be a single deck, can be double deck. That means, in a one screen you can separate it out into two grades. That means, there the your the screen part where we are having this perforated, that is with the holes, we are keeping those plates, we say the different mesh size, we will be talking about it. Now, there they can be of two types, as you can see here, that deck can be horizontal or it can be inclined. That if it is an inclined up to 20 to 5 degree, that type of inclinations can be given over there, and they will be exactly helping you, so that the material will be getting screened. That is, if your depending on the what type of vibrations you are giving, if they are they will be moving downward. So, that your rate of screening can be more, but that will have to be very carefully, that what type of feed material is there, that will be determining whether you can do it or not. Now, that is your normally you will see that screen, it will be below the crusher. Wherever the crushers were there, you have seen gyratory crusher or the your jaw crusher. After that, it will be going to a screen. So, that from the screen, it will be again through a feeder will be loading it to the conveyor. So, normally this small unit for the screening, it will be having its width about your and the length ratio, that is your that 2.5 times the width will be the length. So, that a compact unit can be placed over there. Now, that how the width and the length will be determined, that as I said, that means you will have to make the material at least to go as a layer, they should get exposed to the hole. So, that is why depending on at what speed it is going on, depending on how vibrations you are giving, that you will be designing it. So, the design of this vibrating screen, it is that is an interesting problem. Some of you, if you are interested to work on that side, or if you want to develop your expertise in the maintaining such system, if to be a maintenance engineer, you must know the designing. So, you will have to study over there. That one thing will be, which will be important for knowing to become a maintenance engineer, or if you want to improve the performance of this in the field, how the vibration is given. The vibrations can be given by different method. One, it can be you can have number of your shaft, eccentric shaft can be there, they can be giving a eccentric shaft, or you may have a spring on which this is moving, and with a spring you can allow the vibrations, or you can just the drive itself in the motor, there will be a vibrations coming. So, when you are going for the selections, then we will have to see what are the different type of drives that can be given, and then also while selection you will have to know what are the controls available over there, because that is the same machine. Sometimes if your feed is coming non uniformly, there whether this vibration that your screen can be adjusted or not. Many a time your the screening problem or the soaking problem, or that is exactly you are sending more materials in the oversize, then sending back it to again in a closed loop this, that means you are hand, that is sometimes you are going by that, you are making more finer, then your grade reduced and your performance may go bad. So, that is why you will have to know that in the design how those the drive of this type of vibratory screens are made. Now, you can see here there is a vibratory screen that can be of a grizzly type, that a grizzly type of screen, it can be vibratory or it can be static also. Now, what is the grizzly? Grizzly is just you can see here, these are very that manganese steel rods you can see over here, which are having, it is normally a T section, that your at the top it is wider and then the below it has got a less thickness. So, that if any rock mass, if it go over there, then it will be just if you see that your whenever any material is going, your material that much, if it is that your grizzly rod are of this type of cross section, then what will happen, that if two rods are making like this, the material once it is passing through this, then it will very freely go through here. But if the grizzly rods are very straight eye bar, then what may happen, that means after passing through this, if there is a small one has come and then another small also is coming over there, both get joined over here and then they will be soaking over here, and then this whole thing will not be moving. So, that is why this type of grizzly screens, they must be seen that while in operation they do not give a problem, and then wherever inside that what material will be coming, if there is any jam and or, for that the ergonomically you will have to see, that means any maintenance and other operations that can be done well. While selecting or designing a equipment, you must see that equipment, whether it will be giving any maintenance problem, that is you have to open up a things or clean it, whether the worker can go over there or how quickly it can do it. So, that is another thing, that while selecting you must look into what is called maintainability. In the maintainability, and also whether the operator and all it can do easily, that is called your ergonomically. Now, there will be the supporting frame, you can see the drive is there, that then you have got the friction limiter. So, that means you will be having that your vibrations will be coming, but at the same time on your foundation that vibration should not go. So, that is why the others should not have got, you need to get only the vibration over there, and because the vibration is also noise. So, how exactly we will be doing that part need to be seen over there. So, normally where you use a grizzly, you use a grizzly, that is before the crushing, that means the big that particles which need to be crushed as per the crusher's requirement, that only it will go to the crusher. The undersize can be given to your feed and they can join after the crushing where it will go. If you remember in our crushing we said over there. Now, that means why it is given with a manganese steel, that means it will be much wear resistance and it will be very strong, because when a big rock it will be coming and falling over there, there is a chances of getting its damage, that is why it need to be very robust. Normally what you can find out that when a truck comes over there, that is when your truck is loading onto a hopper, that is suppose you are having a gyratory crushers over here, your gyratory crusher is placed over here. Now, when the material which is placed onto this hopper is made of your grizzly. So, that what happens, that material, if the truck is unloading from here, this material will be, the smaller particle will be going and feed into whatever the conveyor belt is over here, that is from the crusher this material is coming, and then on that this material also will be guided to this. So, that here the material will go for feeding into the next. So, this type of grizzly which is here, that is static, that means there the material is coming and falling and they are doing. So, that is why the vibratory grizzly, where we are having in the processing plant over there, in the receiving section you may have also this what is called your static grizzly. This is your static grizzly, some you will be keeping over here. If the material is coming over there, that is there is a conveyor belt or that another apron feeder will be there, this one will be feeding you to the next process. Your material which is falling over here, it will come like that, and the other side it will go. Similarly, this is what you can see, as I was telling, the T bar for grizzly, static grizzly, it is working like this. So, next thing is another type of screen is very common, that is our banana screen. In mineral in the mining industry, wherever you go to a mineral processing plant, you will be finding this banana screen, because the material flow, that screen is designed just like your shape of a banana. Here they have given this they give your vibration component is here. So, now they are making it to vibrate, the whole screen will be vibrating and the material will be flowing. The flow is aided by the shape, the curvatures given by over there. So, the component wise you have got this floating box that which get vibrations, and then there is a rubber shear spring is provided, so that it can retain the shock, it can be absorbed, it is not going to get other metal damage. Then there will be the screen plates which are there at the bottom, and then this eccentric block, that is your exciter, which is exactly making the thing system to vibrate. So, this type of banana screens are there. Now, coming to the sieving, which is for the finer particle after your things, that this is exactly required for your laboratory as well as industrially you will have to do a different arrangements there for the classifying, but it is a very important to first know that is your how the material characteristics will be there. On the basis of that, you will have to do the designing of your classifier. So, this soil or powder sieving, that is done by very fine mass. Now, mass is your how many number of such square is there in one square inch, that is then 1 square inch number of holes. Based on that, they give a number, sieve number. And then if you see the opening size in millimeter for a sieve number 4, that is your 4 holes per square inch, it is 4.75 millimeter, and then 270 holes, small holes are there, that is a sieving giving your 0.053 millimeter. There could be much more, and then that could be that your either it can be a perforated plate or it could be a screen, and there are number of that your will be from a coarse to your finer, they can be arranged in a stick. Now, what is done in sieving, your nominal size or aperture of the sieve or the screen sieve, this is given by this one. Now, the distance between the wires is called your the nominal aperture. Now, when you will be doing the calculations of how that sieving will be performing, because these wires are also that occupying some space, that will have to be taken care of. Now, the nominal diameter of the wire, depending on that your screen performance will also change. Now, because what is the approximate percentage of the sieving area, that will be calculated by taking out the area taken by the wire. So, that is approximate that your screen area, it is calculated by the total sieve area minus area occupied by the wire, and then the total area of the screen and in a percentage. So, this is the way you define that what will be the screening area. So, when you feed the material or screen the material, how much that material will be having chance to going through this. And then there is another thing, that tolerance average aperture size, this is your some variation in the aperture size is unavoidable, and when this variation is expressed as a percentage, it is known as the aperture tolerance average. So, this is one of the important things you need to keep in mind whenever you will be doing your laboratory experiment with sieving, to find out that is your how the particle size distribution in a things. In find sometimes to know the texture of a soil, you will have to do that. Then the perforated plate also same thing, the size you will have to calculate out how much material is there. So, this powder classifications, it can be done because there could be a quartz powder, there could be moderately quartz powder, there would be moderately fine powder. So, particularly this type of things will be coming in pharmaceuticals or in some food industry. Also in mineral processing, sometimes you may get some very fine powder and very fine powder. Now, this powder can be where it is a quartz powder, there exactly with a sieve number 10, and then in between the sieve number 10 and sieve number 44, whatever is written, that is your quartz size. Similarly, for moderately quartz powder, they are retained between your 22 size and the 60 size, and it moderately fine powder 44 size to 85 number, that depending on the number. As the number increasing, the aperture size decreasing, because that many number of your holes per square inch. So, then when it is a fine powder, they do not say within a between 2 range, it is whatever will be going through, that is your 180 millimeter size, and for very fine powder they are going sieve number 120. So, this is the way they are classified, and accordingly we can get the sieves. So, these sieves you can see there are different, that means if your 10 size means your size is 1.7 millimeter, and then for your very fine powder 120 means 125, things like that. So, there is a ISO standards are there. Whenever you will be doing the studies for standardization purposes, there are so many different number of sieves are available, and the standard manufacturer, they will be giving the sieves in this form. But if sometimes you are doing the laboratory work with weight one, there will be a little bit of design will be having a, so that we can retain the water, there will be a little bit of bigger size, height of this sieve will be more. But this type of sieves will be used, you can see in any material handling laboratory that sieving operations for different testings you will have to have. Now, you know that the procedure is, first you take this whole material, you put them, weight them, that is how first you will have to, when you are going for taking, you have got a sieve rack that how many types, how many different sizes you will be separating. Depending on that, you will be selecting, okay, I will do it 5 sieves, 6 sieves or 7 sieves, you will be deciding. Then you will have to clean it properly. Why? Because the cleaning is very, very important, because whole sieving, how much percentage weight you are retaining, that will be determined by measuring gravimetrically. So, the cleaning of all powder, whatever is left from the previous experiment should be removed. Then you will have to weight it. That after that, your specimen one, which one you are want to get separated, that will be in a first in oven, it will be dried. The dried powder will be placed over there, and putting all one above another, you will be putting in some vibration or shaking things or arrangements, and after some time what will happen, that in each of them there will be certain particle will be retaining, and then rest of the things will be coming and getting at the bottom. So, you will have to do that sample, that is you are having here say sieve number 4, that is a 4 holes per square inch, up to 200 holes we have taken these many sieves, and then their size we know, and then after that is you have taken the material, this total material mass of each sieve, that is your first one retained 765 gram, and then the lower one it gave 509 gram, the total material they have, and finally your which very fine less than 200 is coming 485 gram. Then you do the weight of the sieve and the soil retained, and then you mass of the soil you can find it out, just minus, then you can find out what is the percent retained in that particular one, that because that this percent, then you can find out the cumulatively retained, then you can find out exactly what is the finer fractions over here. Now, these things, then they will be putting that your sieve analysis graph, they will be putting sometimes in your graph of a log normal graph, they will be putting over here, and then they will be finding that exactly how that, what percentage, what is the size, and then how much percent is going through this, and then how much is there. By saying this type of your sieve analysis graph, you will be knowing how the particle size is separated by this. So, this will be very, very interesting when you will be working in the laboratory. Normally in the bulk material handling laboratory, you do this analysis. Now, this is exactly that how you can do these separations, that can be by agitation, brushing and centrifugal force for the finer particles. That vibration or that agitations for screening, it can be given by oscillation, vibration or by gyration. That for the sieve analysis also you will have to have this system, and that can be done over there. That oscillations, that is your sieve will be giving all the time oscillating like that. In a vibration, sieve will be given a vibration like this, then the gyrations, the sieve will be rotated like that. Brushing means with a brush you will be going on handling over there, and then in a centrifugal force what happens within the sieve, it will be rotating. So, these type of arrangements are there in a different type of systems. So, we will be continuing one more class on screening to tell you about that how the screening principles and then the basic things in the mineral processing sections. But you are advised to go through these books of mineral processing by B. Wills, and then there is a very good old book, but very good book, that is your handbook of mineral processing by Taggart. Though I do not know whether the new editions have come or not, but the old edition for understanding the basic principles are important. But what is most important today is you please go through the websites of different skin manufacturer, because nowadays a lot of new developments have come. So, once you know from the textbook that what is the basic principle, but what design coming out of it, it will give you an idea that where exactly the advancements are taking place, and you will have to do that. So, coming to the conclusions, screening and sieving are I have introduced here very briefly, that different type of screens are also just specified. So, that you should be able to tell what are exactly their vibratory screen, what is a static screen, what is a trommel, and then what are the different type of sieves, and basically what is a multi deck, what is a single deck, and then how they are constructed, what is a banana sieve, and what is a trommel sieve. These things you should be able to explain. So, make a study report of what you have learned of the screen and try to do it. Then one more thing I would like to tell you here, that you will be given a Moodle link. So, that whatever we are studying, that you can once again study over there and take some lesson. So, a email will be sent to you, in which there will be a password given, and in that site you will get all this material as well as some of the reference notes for knowing more, and you can submit some of your work also if you wish any special attention by us. Thank you very much.